All right, so this is the fourth lesson in our trigonometry unit, and this one we are going to be looking for an angle. So in the last video we were looking for sides. This time we are looking for the angle in a triangle if we've been given the sides. So the first thing we need to figure out is how do we figure out an angle in this equation? Because before we've always had our angles trapped kind of inside of our sine function there. So then how do we get it out of that? Right now, like here we see sine A is equal to 0.5. Okay, we can't just like divide by sine. It's not like saying sine times A. This is kind of its own thing. This is kind of like the sine and the A right now are together, and they're kind of locked together in a special way, where we can't just like divide by sine. That doesn't work. So what is the opposite of sine? Normally when we like multiply by something, we divide, right? Or if we divide by something, we multiply. We do the opposite to kind of cancel it out. So what we need to do is the opposite of sine. And the opposite of sine would be sine with this little -1 symbol here. And what that -1 means is it means inverse, which means like the opposite. Okay, so this is like the evil twin, okay, of sine or something. It is the opposite of sine. So that little -1, it's not like subtract 1, it's not to the power of -1 or anything, it just means the opposite of sine, okay, sine inverse. So what we end up with is we say to get rid of this sign, we flip it to the other side, but we add that little -1 to make it an inverse. So A will now be by itself on this side, and on this side of the equation, we now have sine inverse, and anything that was over on this side is going to be put in brackets inside that sine inverse. Okay, so we're going to say in brackets now is anything that was inside. So we had 0.5 there. So this is now saying A, our angle A, is equal to the sine inverse of 0.5. And we have to put that into our calculator. So the way we put that into our calculator is that we've already been using the sine, cosine, tangent buttons on our calculator a lot, but right above it, on most calculators, you'll see that sign with a little -1 right above that button. Okay, the way that you hit that button is your calculator probably has like a button that's like the same color as that sine inverse, where it's like blue or orange or something like that. And so it's like my button, my calculator says second, and I have to hit the second button before I hit sine. So let me give you a quick example of that. Okay, so this is my calculator here. Okay, and I know there's some glare there, but there is sine right there. Sine inverse is just above it, and to get to that button, we can't just press the sine button. First, we have to press the second button, and then we press sine. Okay, and that brings up the sine inverse. Now we just punch in like normal, so sine 0.5, or sine inverse 0.5, and that gives us 30 degrees. Sine inverse of 0.5 is 30 degrees, and so we figured out our angle. All right, so our next one is saying like the tan of some angle is equal to 1. Okay, we want to know, well, what angle is that that's equal to 1? So we could try all these different angles and figure out what it is. The answer ends up being 45 degrees. Okay, what works there is 45 degrees. So if you took your calculator and just like normal, you just said tan 45 and hit enter, you would get 1, right? So how we would figure that out other than just by guessing and putting in a whole bunch of things, like put in 1, tan 2, tan 3. Like instead of doing that, we're going to do the same thing, this tan inverse. Okay, so we could have guessed in check here too to figure out that the sine of 30 degrees is equal to 0.5, but this is obviously a much faster way to do that. So we're going to take, to get A by itself, angle A, we're going to do the tan inverse on the other side. So it's just tan with a -1, and then everything that was over here before is going to be inside some brackets, so tan 1. So on our calculator, we're going to do the same thing. I'm going to hit my second button, then I'm hitting my tan button, so it gets the little tan inverse, and 1. And I hit enter, and it tells me what we do there, that it's A is equal to 45. Okay, angle A is 45 degrees. Lastly, this is going to work the exact same way. So the cos of some angle is equal to this number. The angle that this actually is 25 degrees. Okay, so if you put cos 25 degrees in, you would get that. We're going to do this the exact same as with the other ones. To get a by itself, we're going to take this cos and move it to the other side, but now it is cos inverse. Okay, and 0.9063. And it kind of got cut off, but you get the idea. So you put that into your calculator, and you will get we'll get our 25 degrees. Okay, so I'd encourage you to test that out with me on your calculator to make sure that you know how to do it. My calculator right now is saying 25.001, and it has like a very small decimal there, and that's because it is kind of like rounding a couple things. It's not perfectly exact, but this gives us 25 degrees. If we were rounding, it would give us 25 degrees. So this space here was just to fill in this. I just kind of used up here, so I'm not skipping a question here or anything. So the nice thing is now that this is actually all the 3 examples and we're done. Just like before, we're going to use our SOHCAHTOA to try and figure out what we need to use. So that's not SOHCAHTOA. SOHCAHTOA to figure out if we need sine, cos, or tangent. So in this case, in each case, calculate the measure of the indicated angle to the nearest degree. So we want to know what is that angle there. So we are using this as our reference angle. We're looking from here to figure out what's adjacent and opposite in hypotenuse. Okay, hypotenuse is always the same, always across from the 90. And we care about this side. This one we don't know anything about, we don't really care about it. That's the adjacent side, but we care about this one. This side is opposite. So to figure out this angle, we know the opposite and hypotenuse. So the trig ratio that we're going to use is the sine ratio, because that uses opposite and hypotenuse. So we'll set it up. Same as we did before. The only difference here is that instead of putting in the angle in that we know, now the angle is a variable. Sine of angle A is equal to our opposite over our hypotenuse. So our opposite was 4, and our hypotenuse was 6. Now we need to get A by itself. So this is where we do our sine inverse. To get rid of this sine, we're going to move to the other side, and now A will be by itself. So this becomes sine inverse, and anything that was over on the other side is getting put into brackets for that sine inverse. So this becomes in brackets 4 divided by 6. So the way this is going to look in your calculator, because now we can put this into our calculator to get our final answer, is that it is going to say like sine inverse, and it'll have an open bracket. You're going to say 4 divided by 6, close bracket. Okay, so if you do this, that will give you your final answer for what your angle is. Sine inverse 4 divided by 6. So my calculator is telling me 41.8. It's got some decimals afterwards, so I can just round it to 41.8. And this is degrees, because what we were finding was the size of this angle here. So instead of finding the length of a side, we just found out this is 41.8 degrees. So just by knowing those two sides, you can figure out the angle. All right, so let's do the next one. All right, so our next one, we're finding angle B here, and we're going to use our SOHCAHTOA to figure out what trig ratio we need. So in this triangle, this is our hypotenuse, and if we're looking from this angle, then this side is adjacent to it. This is the one that is beside it. So the one that uses adjacent hypotenuse is cosine. Cosine is adjacent over hypotenuse. So cos of angle B is equal to adjacent over hypotenuse, so 10 over 19. We need to get rid of our cos, so we're going to move it to the other side and make it cos inverse. So angle B is equal to cos inverse of 10 divided by 19, which makes B cos inverse 10 divided by 19, close bracket, enter, 58.24. So I'm going to say 58.2. That's just to the nearest degree, I guess. So I'll say just 58. Okay, that one would have been 42 to the nearest degree. So 58 degrees is how big this angle is. Okay, and for our very last example, here it tells us all three sides. Okay, so that might seem confusing, but it just means that we have more options. So this is our hypotenuse. The side adjacent to this is right here, and this one is opposite. So we know all three sides, so we can actually pick any one of these. Okay, we could use the opposite and hypotenuse for sine, we could use adjacent and hypotenuse for cos, or opposite and adjacent for tangent. But let's use tangent since we haven't used that one yet. So we'll say tangent, so tan of our angle C is equal to opposite over adjacent, so 21 over 20. Okay. We need to get rid of our tan, so we need to move to the other side to get tan inverse. So we'll have C by itself, and then on the other side is now tan inverse, and all in brackets 21 divided by 20. So we'll put that into our calculator, and that's it for this lesson then. So make sure you hit that second button so you hit the little -1 there. Tan 21 divided by 20 is 46.3. So we're going to divide, or we'll round to 46 degrees. So angle C is 46 degrees. And that's it. Okay, so you can do, that is how you find a missing angle in a right angle triangle using trig. So good luck with the assignment.